Phrenology began with a powerful promise that personality, intelligence, and moral character could be read from the shape of the skull. To modern ears that sounds obviously wrong, but in its own era it sounded like scientific progress. Instead of relying only on tradition, religion, or social rank to judge people, phrenology offered a measurable method. Practitioners claimed they could examine bumps and contours on a person's head and infer hidden mental faculties beneath. This gave ordinary people a sense that human behavior could be mapped, classified, and predicted with objectivity. The problem was not that people wanted evidence. The problem was that they accepted a method that looked empirical without being truly reliable. Phrenology is important not just as a strange historical episode, but as a case study in how bad science can borrow the language of real science and become socially influential before rigorous testing catches up. The theory rested on several linked assumptions. First, the brain is the organ of the mind. Second, different mental functions are localized in different brain areas. Third, heavily used areas become larger, almost like trained muscles. Fourth, those enlargements alter skull shape, creating external bumps that can be read as indicators of inner traits. Notice why this was persuasive. The first assumptions were not absurd. Modern neuroscience does support the brain-mind relationship and some degree of functional specialization. But phrenology moved too far, too fast. It assumed complex psychological qualities, like caution, benevolence, or destructiveness, could each be tied to discrete modules and then estimated through skull topography. That leap was never adequately justified. A theory can begin with partly correct ideas and still become pseudoscientific if its key inferences are unsupported. Phrenology's fatal error was that it treated a suggestive metaphor as a proven biological measurement system. To understand its rise, we have to place it in the late 18th and early 19th centuries. This was a period obsessed with classification. Naturalists were organizing species, physicians were systematizing disease, and intellectual culture was shifting toward quantification. In that environment, Franz Joseph Gall's framework, emerging around 1796, offered what many people craved, a map of the mind linked to anatomy. From about 1810 to 1840, phrenology gained broad momentum, including institutional centers like Edinburgh, where the Edinburgh Phrenological Society formed in 1820. Public lectures, popular manuals, and personal readings made the system accessible beyond medical specialists. It became a social technology as much as a scientific claim. People used it to discuss education, self-improvement, compatibility, and even governance. Phrenology spread because it offered simple explanatory order in a world experiencing rapid intellectual change, and because it arrived before modern standards of evidence fully matured. Another reason phrenology felt convincing was psychological. Examiners could deliver personality statements that sounded specific enough to impress but broad enough to fit many people. Listeners remembered accurate-sounding hits and forgot misses. Confirmation bias amplified the illusion. If someone already believed that behavior reflected innate differences, phrenological readings appeared to confirm what they expected. The ritual itself also created authority. Careful touching of the skull, technical labels for faculties, and diagrams of cranial zones made the process feel clinical. But appearance is not method. Even by the standards of the 19th century, many critics challenged phrenology's rigor. Its measurements were inconsistent, its trait definitions were vague, and its predictions were often retrofitted after social impressions. A robust science requires clear hypotheses, reproducible procedures, and tests that can fail. Phrenology often produced confident conclusions without that framework, which is exactly why it was vulnerable to collapse once experimental and clinical evidence became stronger. Experimental physiology played a major role in dismantling phrenology. Marie Jean-Pierre Flourens used ablation studies, removing or damaging specific brain regions in animals and observing resulting functional changes. His findings did support a differentiated brain, showing that major structures could have distinct roles. But they did not support phrenology's detailed map of personality faculties tied to skull bumps. This distinction is crucial. Flowerens did not prove the brain was undivided, he showed that phrenological localization claims were inaccurate and overdrawn. Instead of speculative interpretation, he used intervention and outcome, alter a structure, observe what changes, compare systematically. That method was harder to manipulate and better suited to causal inference. As evidence accumulated, phrenology's fine-grained trait chart looked less like discovery and more like projection. The field had claimed predictive precision, but controlled tests failed to validate that precision. The deeper neuroscience question survived, while the phrenological answer did not. Clinical neurology delivered another decisive challenge through Paul Broca's work. Broca investigated patients with focal brain lesions and linked specific deficits to specific damaged regions. In one famous pattern, patients could still understand language relatively well but struggled severely to produce speech, associated with lesions in the left frontal lobe region now called Broca's area. This result mattered for two reasons. First, it supported functionally specific brain organization in a testable, medically grounded way. Second, it undermined phrenology's skull reading framework, because the evidence came from pathology and behavior correlation, not from cranial contour interpretation. Broca's findings showed that localization can be real without validating phrenological categories. In fact, they highlighted how crude and inaccurate those categories were. The transition from phrenology to modern neuropsychology was not a rejection of all localization ideas. It was a shift from decorative maps and confident speculation to constrained, evidence-based models anchored in observable clinical outcomes. This creates a nuanced historical verdict. Phrenology was discredited as a predictive science of personality from skull shape, yet parts of its broader intellectual agenda fed into later progress. Gall's insistence that mental life has biological correlates helped normalize the idea that the brain should be studied as an organized system, not a uniform mass. But legacy does not mean vindication. A wrong framework can still push useful questions into mainstream debate. Science often advances by separating valuable questions from invalid methods. In phrenology's case, the valuable question was whether the brain has internal division of labor. The invalid method was claiming to read that organization through external skull features and map it directly onto moral and social traits. The history matters because it teaches a discipline. Do not confuse directional intuition with demonstrated mechanism. A theory can point toward truth while remaining false in its main claims, and phrenology is a textbook example of that paradox. Why is skull contour such a weak predictor of complex psychology? Start with anatomy. Skull morphology is shaped by development, genetics, growth patterns, and structural constraints that do not provide a high-resolution mirror of cortical function. Then consider psychology. Traits like impulse control, empathy, risk preference, or verbal fluency emerge from distributed neural networks interacting with environment, learning, stress, nutrition, social context, and culture over time. They are dynamic processes, not static bumps. Even when neuroscience identifies regions associated with functions, associations are probabilistic and network-dependent, not simple one-to-one organs of character. Methodologically, phrenology also failed to enforce standards now considered basic. Independent replication, controlled comparison groups, clear operational definitions, and statistical tests against chance or confounding factors. Without those safeguards, interpretation drifts toward storytelling. The central lesson is not merely that phrenologists were mistaken about details. It is that their entire inferential pipeline lacked the constraints needed for trustworthy psychological measurement. Phrenology also had social consequences that make it more than an academic curiosity. Any framework that claims to objectively rank people's capacities can be used to rationalize inequality. When biological language gets attached to moral judgment, social bias can be repackaged as scientific necessity. This pattern has repeated in many forms across modern history. Phrenology demonstrates how quickly descriptive claims can become prescriptive rules about education, employment, criminality, and status. That is why this history still matters in the age of algorithms, biometric scoring, and and predictive analytics. New tools may be mathematically sophisticated, but they can still inherit old errors, overconfidence, weak construct validity, hidden confounders, and harmful categorization. The right response is neither blind trust nor blanket rejection. It is rigorous scrutiny. Ask what is being measured, how reliable the signal is, what uncertainty exists, and who bears the cost when the model is wrong. Scientific literacy includes ethical literacy. A modern point of confusion involves research on archaic human skull interiors, sometimes criticized as paleophrenology. The label is usually a warning against overinterpretation, not a literal equation with classical phrenology. Contemporary researchers may analyze endocasts and intercranial surfaces to infer broad developmental patterns in extinct populations. That work can contribute cautiously to discussions of cognitive and communicative evolution, but it operates under different assumptions and standards than phrenology. It does not claim to read individual moral traits from bumps, and responsible researchers frame findings probabilistically, cross-checking with archaeology, comparative anatomy, and evolutionary theory. Still, the warning is valuable. Whenever data are indirect, narrative inflation is a risk. The boundary between inference and speculation must stay explicit. So the presence of skull-based evidence in modern paleoanthropology does not revive phrenology. It highlights a broader principle. Similar-looking materials can support very different sciences depending on method, scope, and epistemic discipline. The enduring lesson of phrenology is that science is not defined by confidence, instruments, or technical vocabulary. It is defined by how claims are tested, challenged, and revised. Phrenology offered certainty where uncertainty was warranted, simplicity where complexity was real, and social authority without sufficient empirical discipline. Its collapse was not a failure of science, but an example of science correcting itself through stronger methods. From Floweran's interventions to Broca's clinical correlations, evidence replaced assumption step by step. For us, the practical takeaway is clear. Stay alert when bold claims reduce human identity to easy biological shortcuts. Demand transparent methods, replicable results, and proportional conclusions. Respect nuance, especially when claims affect people's opportunities and dignity. Phrenology's story is not just about a discredited skull theory. It is about the recurring human temptation to mistake elegant narratives for truth, and the continuing responsibility to earn our conclusions through rigorous evidence. If you found this helpful, please like this video and subscribe for more explainers.